Hello. Hey, everybody. Good evening. Welcome to reInvent. Today, we are going to talk about unlocking the power of application monitoring. My name is Siva Guruvarediyar. I'm a senior specialist architect focusing on observability. So with this one, let me start with this anecdote, right? Everything fails all the time. So this was a famous quote told by Dr. Werner Vogels, Amazon CTO. So you might be asking the question, why things are failing all the time, right? Because today's applications are pretty much complex in nature. We all writing microservices, right? Just show me your hands if you're not using any microservices and still using monolith. Nobody, right? So when you are writing a lot of microservices, you are writing many programming languages, many frameworks, and many SQL, SQL, NoSQL, and many different components. For example, you might be using Kafka or other third-party vendors or third-party APIs and all those, right? So in this kind of complex application environment, you have a conundrum in place. For example, in one side of the house, your developers and your product teams wanted to ship many more products faster and faster. And also, they wanted to scale it in such a way that, you can reach your customers in a fast-paced manner. But at the same time, if something is break in production, you wanted to make sure, you want to fix it as soon as possible. Basically, you want to detect it and then remediate it as soon as possible. And even better would be if your customer is not getting it, if you can get it and then rectify that error, that would be awesome, right? So why or how we can achieve that? That is where the application observability comes in, or applications monitoring comes in. Why this application observability? I'm always a fan of why. So I always ask why, right? Why should I do this application observability? What I'm going to get in return, right? First of all, if you start to observe your applications, you will be able to understand your application health. And then also, with this one, you are going to be getting improved performance and availability for your end customers. So that is going to be indirectly reducing your operational cost, because you know what you're working on. You know what you are doing, basically, right? You are not treating your application as a black box. It's basically, each and everything, how it is connected, and all those things, right? And last but not least, that is also going to drive your improving your end user experience. Because as I mentioned, even before your end users are going to get any issues, you are going to get those problems and then fix it, so that you are going to have happy customers. Who doesn't want a happy customer, right? So with this one, we have the AWS suite of products. We have the open source side of the house and then AWS native way of doing things. So this is how our AWS native way of doing observability. Coming from bottom up, so starting with the instrumentation, right? So this year, we launched something called Unified CloudWatch Agent. So till last year, if you want to send your metrics, you might need to install an agent. And then if you want to send your logs, you need to install an agent. And then if you want to send traces, you need to install another agent. There are agents everywhere, right? But with this Unified CloudWatch Agent that we launched this year, only one agent will be doing all the jobs. So with only one agent, you can send metrics, logs, and traces. Just one agent. That's all you needed. On top of it, you are sending your signals, basically the metrics, logs, and traces to CloudWatch. And then you can create your custom dashboards using CloudWatch, or you have your metric explorer, or you might be interested multiple accounts, you are having it. You might want to designate one account as a monitoring account so that you can achieve cross-account observability, right? So, but the story doesn't end there. You might be running many containers in your environment, or many lambdas in your environment, or you wanted to have lot of logs, how it is behaving and all those. So that's where we are having a lot of insights, like container insights. We have lambda insights. We have log insights. So each and everything, they are doing their own job. If you are wanted to do only containers, you have container insights, for example, right? On top of all these things, so that's where our application signals come in. So you might be asking, what is application signals? it is AWS's opinionated way of APM, like doing applications performance monitoring. So with this application performance monitoring, it is always like integrated with the existing stuff like synthetic canaries or like real user monitoring. All these things, so you don't have to run around like multiple paces. You don't have to open multiple tabs to go and figure out like if something is broken. With a bunch of clicks in one particular place, you should be able to do it. And that is not all that, right? You're also having like metric streams. So if you want to send your metrics or logs maybe to a third party, or like you might wanted to send it to your on-prem, etc., right? You might send it using like metric streams, and then also like all these things are based on open telemetry. That's open standards. So with this one, like this is what like the key application metrics that we are talking about. So this is nothing new in the world of APM. Like you have all these red metrics. So R stands for request, E stands for errors and false, and then D stands for duration or latency. So this is what we call as red metrics, the golden signals of APM. All our application signals is doing is, it is all revolving around the concept of these red metrics. So you'll be having like all the red metrics from one particular place. So with this one, like again, coming back to the question, how does it work under the hood, right? So starting from the left-hand side of it, you are having your application signals. So you might be using like open telemetry. So you don't have to bother about like hey, will I be doing some kind of vendor lock-in? You don't have to worry about it because it's all based on open standards. It is the same standard that is coming out of CNCF, that is a Cloud Native Computing Foundation, the same foundation that is taking care of the projects like Kubernetes, Prometheus, Grafana. They are the ones like taking care of open telemetry, and this entire application signals is based on open telemetry, so open standards. So you don't have to worry about vendor lock-in. So on top of it, like today we are supporting 4 programming languages: Java, Python, .NET, and Node.js. So if you are using any of these languages, like you don't have to write even a single line of code to instrument your application, because open telemetry's auto instrumentation will take care for you. And from the computing side, like we are supporting EC2, ECS, EKS, and not only EKS, like Kubernetes. If you are using like on-prem Kubernetes or some other flavors like Rosa and all those things are supported. So if, for example, like if I'm running a Java application and then I'm running on EKS, it's pretty straightforward. Just enable an add-on, and that's it. Using the unified CloudWatch agent, that is just one agent, so that will be used as a vehicle, so that your metrics, logs, and traces, all those things will be shipped to the destination. So for example, like your metrics and logs will go to CloudWatch, and your traces will go to X-Ray. On top of all these things, you have an out-of-box dashboard coming from application signals, wherein like you will be able to correlate your metrics, logs, and traces. You can create SLOs, etc., right? Which I will demo in a bit. So how or what are the things like you are doing it if you are doing all these things, right? First of all, like you can collect telemetry signals. So what do you mean by telemetry is, as I said, it's based on open telemetry, open standards, and then it is backward compatible with X-Ray. For example, today, if you are using X-Ray already, we will take the trace from you, and then we will convert into spans, hotel spans, so that you don't have to do anything, and then it is all backward compatible. With Unified CloudWatch agent, you are running fewer agents, and again, as I mentioned, like everything is backward compatible, so you don't have to do any kind of code changes for this to be effective. And then the second one is discovering the services. So since we are all in a microservices world, you don't have to say like hey, my microservice A is calling my microservice B, etc. By default, like with all the signals that you're sending, we will be able to see how these signals are correlated, and then we will be dynamically creating this kind of maps. Also, like in the services view, you will be able to see how these things are like running under the hood. So the next one is like troubleshooting with any kind of metrics and traces. Okay, so far so good, but in my production something is broken. How do I go and fix it? It's as simple as like bunch of clicks. So just go to this particular UI, which I will demo in a bit, and then click on some of the anomalies that you are seeing from the graphs, and then using some of the clicks, just go to the transactions using the traces, hotel spans, and then it will show you at exactly which particular line number it is failing. And the another thing is SLOs, right? Service level objectives. Just a quick 101 on SLOs. For example, from your services, you are sending your metrics, and that's what we call it as SLIs, or service level indicators. So service level indicators drives your SLOs, or service level objectives, and from SLOs, you are creating your SLA, or service level agreement. Basically, this is a same kind of a thing, but it is used by different persona. For example, the SLIs are dealt by your development teams, or your engineering teams. And then your SLOs, or your product managers will be talking about, hey, my service is 99% available, right? And then the SLA basically says your salespeople will take it and then say to the customer, saying that my SLO is 99%, and then if I'm not meeting that SLO, there will be penalty. Typically, there will be a monetary penalty and all those. So that's how the entire ecosystem works. And with this one, let's take a very quick example, right? So for example, I'm calling my service, and then I'm saying it is 99% available in a period of a month. So how we can do this calculation? For example, this one, there are 43,800 minutes in a month, and then since we mentioned 99% availability, the rest 1% is 438 minutes, which is roughly equivalent to 7 hours and 18 minutes. So this is what we call it as an error budget. So even if it is 7 hours, 18 minutes, and 1 second, so that means your SLO is breached. So you can maybe create a pager alarm, or you can create a CloudWatch alarm on that, and then you can inform your SREs so that they can take some action on it. So far, people have been writing a lot of spreadsheet and algorithms for this to come up with an SLOs, but with application signals, with a bunch of clicks, you can come up with SLIs and SLOs in no time, right? And last but not least, as I mentioned, you are having your synthetic and client integrations in one particular place. So synthetics, if you want to ensure maybe you are running some websites and you wanted to make sure it is always up and running. So you might be running some canaries, and then say if the canary fails, you want to make sure your developers are informed so that they can fix it. And also real user monitoring. So real user monitoring, for example, we will give you a snippet of JavaScript code, which you can take it and then put it into your static files, and that's it. You can forget about it. So from your browsers, customers' browsers, the metrics will be directly sent to CloudWatch, and from there, you'll be able to know what your customers are experiencing. Are they experiencing slowness? Are they experiencing JavaScript errors? Where they are coming from? Which part of the world? All those things can be coming from one particular place. So all these things are integrated. So you don't have to run around, as I mentioned, multiple different services and all those things. It's a combined thing, right? So not only that, we are talking about application layer, right? So you might be wondering, okay, so are we working in a silo? Are we only considering applications only? So what about infrastructure layer, right? So that's where we wanted to bridge the gap between applications and then infrastructure layers. So with this one, we have application signals is having a very tight integration with container insights. So if you're running EKS or ECS or any container environment, from application signals, you can easily transform to container insights, or from container insights, you can directly go back to application signals. So it is seamless, right? And especially if you're using EKS, it's just as simple as enabling an add-on. Just go and then enable this CloudWatch add-on, and that's all. You don't have to do any other thing. With this one, it can easily enable this, and then application signals will be there. So far, so good. So let's take a quick demo on this. So if you're going to CloudWatch for the first time, if you have not experienced this, so under application signals, you will be able to see all the different options. So as I mentioned, when you are enabling it, when you're coming for the first time, you can go to enable application signals and then choose your platform, whether it is EKS, ECS, Lambda, anything, even your on-prem, right? And then today, we are giving two different options for you to enable it. One is console, the way we are doing right now, or you might want it to do in your CI/CD pipeline. So that's the manifest file. So currently it's an EKS environment. So what I will do is I can just copy paste this 2 lines and then put it into my CI/CD pipeline, and that's all. I can enable my services for application signals, right? So once you do that, and when you're coming for after your metrics are reaching to CloudWatch and all those things, so this is how the out-of-box dashboard will be looking like. For example, you will be seeing from the SLI status how it is behaving. Then, as I mentioned, everything based on red metrics, request, error, and duration. So we will be showing top services by fault rate, then top dependency paths by fault rate. You may be wondering why dependencies? It's a microservices world. So your application failing doesn't mean that only your application failing. Maybe your dependency might be failing, and then that is having some cascading effect, right? So that is why we can show that, and also you can come down to services. It will show you where these services are running, hosted in EKS, ECS, EC2, etc. And also what are the top operation dependencies. So all those different graphs will be there. Just hover over it, it will show you how it is behaving. So from here, if you are a CloudWatch alarm fan, you just click on this bell icon, and then it will take you to the page. Just create an alarm from there. That's all it is, right? And then the next one is the service map. So dynamically, we are creating this map for you. You don't have to send any signals. Maybe on the first look, it will show as if it is a trace map, X-ray trace map, but it is trace map on steroids, right? So you will be getting a lot of information. When you're clicking on any of the nodes, you will be able to see the request, latency, etc. And also, if you click on any of the edges, it will show you how it is behaving, what is the average latency, etc. Right? And also if I go back to this one, so this is how the macro level. So far we talked about the macro level. Let's go to the micro level details. For example, this is a billing service which is coming from Python. So when I'm going for the first time, it will show me the different operations, the dependencies, canaries, client pages in one particular place. And also it will show me my latency, P99, average, P50, P90, etc. And also, if I go to the service operations, so under this, I will be showing all these things. The important thing here is we are seeing some anomalies on the latency. So let's go and see why there is a spike in latency. Just click on this. So it will take you to the correlated spans. And from here, I just click this one. So it will take you to the trace page. So from here, it's not only the trace details. It's going to be showing you multiple information, starting with the trace details, and also the span timelines. Each and every hop, how much time it is taking. For example, if I'm a Java developer and I'm only worrying about pet clinic frontend, so I can go and see why it is taking 1.65 seconds in that particular hop, right? And also if I'm sending any logs, I will be able to see from here. The next one is also this dependencies, I can click on it. For example, this put call is having 4 different dependencies. I can come over here, and then I can see it is having some DynamoDB dependency, some STS, Postgres, etc. And from here, if I wanted to enable this, and then I can click on this guy, and then it will show you different latencies, spikes, etc. Again, we can do the same operation. So the another interesting thing is the SLOs, right? We talked about it. So if I want to create a SLOs, today we are giving 2 different options. One option is using the SLIs, service operation. So after you enable these application signals, you can create your SLIs based on the service operation. The other option is using the CloudWatch metric. So you don't want to use any of the application signals, that's totally fine. You can create an SLO based on your CloudWatch metric as well. For example, I can choose the service operation. I can choose some random service like customer service, and then I can choose some operations like maybe post operation, and then I can say, is it based on the request or based on periods, right? And then I choose what should be my latency, and then I can say it should be less than 100. So that's all. You just created your SLI from here. Then you can go to your SLOs. So I might be wondering what it will be in a 1 month time window. So in a 30 days rolling window, I wanted to achieve 99% of the time. So that means it is going to show you what your SLI is, what your SLO is, and also you will be able to create any alarms. So today we are supporting alarms. You can create it on SLIs or SLOs or SLO warning, because you don't have to wait for your SLO to be triggered, right? So you can create some threshold here, 30% or something. So I can say 30%. So when that 30% mark is hit, it will create an alarm. also, right? And finally, like, synthetic canaries, you can write your synthetic canaries. And then from here, like, I will be able to go and look into my different canary runs. For example, like, and I can say, like, this particular canary ran for multiple times, and then which are all the different steps, and then the screenshots. So this is how, like, your users are going to see your application real time. So we are going to take all these things from this particular place, and also, like, logs also, and HTTP archive files also. The same goes for RAM, right? So with this real user monitoring, as I mentioned, we'll be giving you a snippet of code, just place it, and then from there, like, it will be coming back to you, right? So this is how, like, the overall flow is going to be. So let's switch back to the presentation. So that's all I have. So in a nutshell, like, I just want to show, like, application signals is a opinionated way of doing applications performance monitoring. So with all these things, like, the SLOs or correlating metrics, and especially this is based on open telemetry, you don't have to worry about the vendor lock-in and all those things. So thank you so much for your time. And these are all the different resources that you might be using it. So we do have an observability workshop. All those things are free for you, like, it doesn't cost anything. You can explore, like, some of the best practices that we are talking to multiple customers. We have multiple best practices that they are opening up. And also, like, we have some accelerators based on Terraform and CDK we have today. So if you wanted to start your journey, you don't have to start from zero. We already have some ready-made scripts for you. You can take a look into it, and then you can start with the accelerator. And finally, there is a skill builder course, which is dedicated for AWS observability, which is totally free for you. And please take a look into it, and then please reach out if there are any questions. And please submit your survey results. This is COP359. And also, like, if you wanted to know more, on Thursday, 3:30, we have a session, COP409, wherein, like, we will be going more depth into this application's performance monitoring. So if you're interested, please reach out, like, COP409 on Thursday. So thank you so much for your time. Happy week.